let's look at quantum numbers. They are another way of saying an electron's position or where it's in. In other words, quantum numbers are three numbers. There is a fourth one, but we're not doing the fourth one. Anyway, three numbers that will tell you the energy level, orbital shape, and also which specific orbital an electron is in. The first one is the principal quantum number. And we already know what this is. It's what we've been saying is the principal energy level. For this set up here, the principal quantum number is 3. It's the first one in the series. And so this particular electron is in the third energy level. A few things about N, some of which we already knew, that N determines the energy of the electron principally, or it mainly governs the energy of the electron, but also as far as the size goes. The higher the N, the higher the energy. And we've been showing it that way. But also the higher the N, the principal energy level, the larger the orbitals. And we kind of knew that already just looking at Bohr's model. If you have the nucleus, and as you go out, the energy levels get bigger and bigger. So really the orbitals are getting bigger and bigger, even though they're not really shaped like those circles. So that is the principal quantum number. We also have a secondary quantum number, sometimes just called the angular momentum number. It tells us basically the orbital shape or type, and we're talking about SPDF, that kind of thing. So basically we're going to take those orbital types or shapes and give them each a number, and we'll just describe it using the number instead. So all you have to remember is that S is 0, and then from there it just counts. Okay, so here's an example. What are the first two quantum numbers for an electron in the 4p sublevel? Well, the primary quantum number is just the energy level, so it's 4. And the second quantum number, the secondary, is going to represent this p, and we just said that p is 1. So those are the first two quantum numbers for an electron that is in the 4p sublevel. The third quantum number is the magnetic quantum number, and this tells basically which orbital in that sublevel something is in. It tells the orientation in space, and we'll see a figure in a minute. But basically, like on the 5p sublevel, we know that there are 3 different orbitals, and so we're going to number those so that we can say which of those an electron is in. And this is the way I remember, like how what the possibilities are for the numbers. And that is, what I do is I assign the middle one 0, and then to the right I go positive. This one only has 1 there, and to the left I go negative. And that kind of tells me what the possible magnetic quantum numbers are for that sublevel. So let's just say I'm going to do the magnetic quantum numbers of this electron here. The primary would be 5 because that's the energy level. The secondary level, or the secondary number, would be, it's p, and we said p is 1. And then the last number just tells us which one of these, and I put it in the -1. Okay. We don't necessarily correlate this drawing with which number goes here, but it does make it easy kind of to remember the possibilities. Some people will put it in terms of the secondary number as far as what they could be, what the values could be. And so if the secondary number is 1, as it was here, this one, then the magnetic quantum number can go from -1 to +1, which is what we came up with up here. Let's just look at this other example with D to kind of see what we would have. So for these quantum numbers, they're all going to start with 5 for the 5th energy level. And then if we look back on our secondary, D is 2. And then the possibilities on this 3rd number, I can figure that out by my little drawing. That I'm going to have anything from -2 to +2 for this 3rd number, which is kind of how this worked. And this is what we're talking about the different orbitals. These are all p orbitals. And you know that when you have a set of p orbitals, there are 3 different ones. Each p orbital has 2 lobes. That's going to be very important as we go on to the next unit on bonding. So that is actually 1 orbital, and it's side to side. This one, this is all 1 orbital. It's oriented front to back, and this one top to bottom. So that 3rd number tells you which one of these you're talking about for an electron. This is a summary that kind of tells what is possible for the 3 different quantum numbers we've learned. And a lot of times, the questions are such that you're trying to decide what the possibilities are for the 2nd number if you know the 1st, what the possibilities are for the 3rd if you know the 2nd, and stuff like that. It helps you understand the structure about how the electrons are arranged. And so this is kind of a guide. Let's look at an example problem. So in this example, you basically have some sets of numbers, and you have to kind of go through and see what's possible and what's not. We're supposed to find the one that is a possible combination of quantum numbers. So just going through, when you do these, what you do is look at each number and say, is that possible? So the first one, this first set, I look at my first number, the primary quantum number, which is for energy level. And there is no 0 energy level. So n cannot be 0. And so this one is not possible. Okay, next one, we look at our first number, 1, and certainly there is a first energy level. And so that's possible. Then we go to the next one and say this one is 2. Well, what does 2 mean? This would be n equals 1, and then this is the type of orbital, and 2 stands for d. And so we say, does the first energy level have d orbitals? And no, it doesn't. The first only has s. And so really the 2nd number, when this is 1, the 2nd number has to be 0 because there's only s. Anyway, this one is not possible because that combination of energy level and orbital type doesn't occur. Okay. When we go to the next one, 4th energy level, that can happen. 0, that can happen. Basically, we're talking about the 4s sublevel. But then when we go to this 3rd one, we see a -1. And if we're in the 4s sublevel, there's only 1 orbital there, and its magnetic number, its 3rd number, would be 0. So that's not possible. Let's cross that one out. So let me go back and fill these. So n equals 1 only has s orbitals. That's how we did that one. And on this one, the magnetic quantum number must be 0. And anyway, that's how you figure out this one is possible. This would be the 4th energy level. 2 is d orbital, and it's +2. And we know that that's possible because if we number this, we see that it would be here.